Hello, my name is Nathalia and I'm going to present our work, an item response theory analysis of algorithms and programming concepts in App Inventor projects. This research was carried on by the Software Quality Group at the Federal University of Santa Catarina in the context of the Computação na Escola initiative. Today we live in a technological world in which computing has an increasing influence on our daily lives, so teaching computing in K-12 has emerged as an important matter, especially teaching coding and programming. Computing education is often introduced in K-12, focusing on algorithms and programming concepts using block-based programming environments, such as App Inventor and Scratch. App Inventor allows creating Android apps and program by drag-and-drop visual blocks. However, aside from using environment for novices, we know that programming is hard for multiple reasons, such as high mental load and so on and so on. Therefore, we should design a learning progression that puts easier concepts first and harder later, providing scaffolding as the students progress upwards. So, what is a learning progression? Well, basically, it is a pathway in which students travel as they progress toward mastery of skills. To help us build that, we can use scales. Scales are very useful because they allow us to distinguish what is easier and harder from the learner's point of view. Thus, the research question is, what is the demonstrated difficulty of algorithms and program concepts in App Inventor projects? So we follow these research methods, starting with research design. Then on study execution, we have data collection, including app crawling from the App Inventor gallery. Then we assess these apps using the Codemaster rubric. This got us a data set in which we analyze using R language. With this dataset, we estimated the parameters of item response theory and also plot some interesting graphs such as right map and item characters curves. Then on the last step, we analyze and interpret the results. On a more detailed view on data collection, initially we collected data in the form of App Inventor projects. We downloaded the publicly available apps from the App Inventor gallery. As a result, we obtained the source code of 80,000 App Inventor apps. We assessed these apps using the Codemaster tool, resulting in a big table of raw data. Here I present just a taste of the Codemaster rubric. We have 15 criteria and performance levels defined for each criteria. Please see your paper if you are interested in more detail on this rubric. Here we have an X-ray of assessment data. We can see that some items seems to be hard because they have very few points above 0. On the other hand, for example, events seems to be easy as many projects received a grade above 0 points. So let's jump into the results. In order to analyze the demonstrated difficulty of algorithms and programming concepts of App Inventor projects based on the Codemaster rubric, we use the item response theory gradual response model proposed by Samejima. IRT allows analyzing item properties such as difficulty and discrimination. So this is done by estimating the correspondence between an observed latent trait, in this case the demonstrated difficulty of algorithms and program concepts of App Inventor projects, and observable evidence, in this case the assessed App Inventor apps. The gradual response model assumes that items are polytomals and its response categories are ordered such as in the Codemaster rubric with many performance levels. The B parameters are the difficulty parameters items that present B parameters values far below the average are considered easy, as they result in a high probability of an average individual satisfying the item's category. Similarly, items that present high B parameters far above average are considered difficult because of the low probability of an average individual to satisfy the item's category. Analyzing the results, we can infer that the easiest category is the first category of item 15, screens, as it presents the smallest B parameters. B2 equals minus 2.53. On the other hand, obtaining 3 points for the item lists is more difficult than any other item, as it presents the highest value for a B parameter. B4 equals 5.20. We have visual plots that make it easier to compare these B parameters, so let's see these results on a right map. From the placement of items on the scale, we can infer that an item with a B parameter estimated at 1.5 is 1.5 standard deviations above the average ability. Such item is more difficult than all items that are placed below 1.5 on this scale. In the context of programming with App Inventor, the easiest items include item 7, events, and item 15, as these items have negative B parameters far below 0. These results are semantically consistent, as App Inventor encourages unlimited use of events and creating screens that change as an essential function of useful mobile apps. The most difficult items include lists, data persistence, and sensors. For example, the third category on lists has the highest demonstrated difficulty parameter, the B4, being the most difficult to achieve among all items. Another visual plot that makes it easier to compare these items is the item characters curves. So let's see these ICCs. While the theoretical range of a latent trait is from negative infinity to positive infinity, for practical considerations, the range of values can be limited from -4 to 4 on the x-axis. Items with low demonstrated difficulty are placed closer to low latent trait values, and high demonstrated difficulty items are placed closer to high latent trait. It makes sense, right? Thus, items that have high B parameters, which indicate high demonstrated difficulty, such as item 5, lists, and 12, sensors, present the curves dislocated to the right. Following this idea, items with low demonstrated difficulty, such as item 7, events, and 15, screens, present curves dislocated to the left. Well, in general, these results can be summarized as 3 groups of demonstrated difficulty levels for algorithms and program concepts in App Inventor projects. Variables, strings, naming, events, and screens are the easiest concepts when programming with App Inventor. As we saw in ICCs, the all probability curves are dislocated to the left. Items with medium demonstrated difficulty include operators, conditional synchronization, procedural abstraction, and drawing and animation, as the probability curves are close to the average, the 0.0 latent trait. The most difficult items are lists, data persistence, loops, and sensors, as the probability curves are dislocated to the right. So we've presented a database analysis of the demonstrated difficulty of algorithms and program concepts based on App Inventor projects. A manual organization by computer science teachers may achieve similar results. However, this work does not support the findings based on opinion but data. These results can help to improve the teaching of algorithms and programming in a more effective way in alignment with scaffolding support. As future work, it would be interesting to compare our results with experts' opinions and also to discuss and improve the sequence of instruction units for teaching algorithms and programming with Inventor. Thank you for your attention. If you are interested in more details, please read our paper. Thank you very much.